So in the previous part, we looked at how we can create intricate mosaic patterns where we isolate certain features of a tile, adjusting them individually. In this part, we're not going to be looking so much at how we can work with individual tiles, but rather how we can integrate multiple different systems together, such as geometry rasterization, tiling, UV warping, all into a single texture so that we can end up with extremely complex textures. To do this, we're going to begin with a SOP network that we can just call complex patterns. Inside of here, we can go ahead and drop a copnet, and we can call this complex pattern texture. Okay, inside of here, let's go ahead and cover something that we covered in the first video, and that is the use of UVs. So if we go ahead and drop a tile pattern, this creates this uniform grid for us. However, we can actually use this as an image and warp it in UV space. So if we were to use a UV map and then take a UV sample and plug our tiles into the texture and our UV map into the UVs, you'll see that nothing changes when we set our display flag on the sample. That's because this is your default UV space. This is where 0, 0 is in the bottom left and 1, 1 is in the top right. And by default, the tile pattern follows that. So this does, of course, allow us to do things like distortions and things on the UV map. So let's just use a distort. And you can see that by default, the distort actually just pans a texture. So if we increase the scale, you'll see that it just pans left or right. But if we were to use something like a noise, so a fractal noise with its signature set to UV, plugging that into direction, you'll see that as we increase the scale, it distorts that grid. So that's already something that could be quite useful for you. You could make all sorts of distortions occur through a particular tiling pattern. And this works for all tile patterns because we're not actually affecting the tile, we're affecting the UV space. So we're distorting UV space and then sampling the distorted space. So what are some other ways to generate UVs? Well, one of them is to use ramps and actually create our own UV space. So if we use a ramp mono right here, you'll be able to see that it runs from 0 on the left to 1 on the right. And if we were to set it to vertical, then it runs from 0 at the bottom to 1 at the top, which is much like having X and Y coordinates. So if we duplicate this, and we have the one ramp running horizontally and the other ramp running vertically, this can be our X coordinate, this can be our Y coordinate, and then we can use a channel join. So if we use a channel join, we can put the horizontal ramp into the first input and the vertical ramp into second input. That gives us this. Now, this may not look exactly like our original UVs, but it is actually the same thing. It's just different colors being shown. But really, if we were to put this into blue, that's the same thing. The only difference is that when we use things like a UV map, it just uses red and blue as opposed to red and green. So we can put this back into red-green, and it's the exact same thing. Now, over here on the channel join, we'll also change this to a UV, so that the output is no longer RGBA. But if we plug this into this UV sample, you'll see that it looks different. The scaling is different over here. And the reason for that is because UVs in Copernicus actually go from -1 to 1. And there's a bunch of easy ways to fix this. You can remap these ranges if you want. So remapping over here so that each one of these go from, instead of 0 to 1, from -1 to 1. So I'll put the same one over here. Like that. You'll see that these are now the same. And these are now our UV coordinates. So they look a bit different, but it's the same thing. Alternatively, you can also transform these UVs using a UV transform. So after the channel join, all you would have to do over here is increase the uniform scale to 2. And if we take a look at that, now it is the same. Cool. So that's how we go about actually generating our own UVs. Now, if we were to warp these spaces, we can do them individually. But another interesting thing that we could do is if we were to change this ramp to radial. So one radial channel and one vertical channel. And let's see what that gives us. It gives us this. Now, this isn't exactly what we want out of this because we want to generate a radial pattern. So to do that, we go down here to our second ramp and we can set it to concentric. When we do that, we'll actually end up with a radial tile pattern because we're using this for X and this for Y. And when we join it together, that's our UV. We're still scaling it up by 2. And then when we sample, we end up with this. Now, the second ramp at the bottom is where most of our changes are going to occur. For example, if we reduce the upper end and increase the lower end, we end up with something like this, which in my opinion is much nicer for the look that we want to go for. So I'm going to increase that a little bit further, just to something like that. Now, one thing that you will notice is that by default, we have a uniform grid, but when it gets distorted like this, we actually don't have that same uniformity. You'll see that we have a lot more of these concentric shapes than we do radial. So to change that, we can use a multiply constant, plugging that into our radial ramp, and then increasing the brightness on it. So basically increasing the multiplier until it's back to more or less a uniform grid. So something like that. Now, because we have this set up, it's really easy with our tile pattern to now make adjustments over here. You'll see that it does sometimes flash in and out, and that's not a problem. What we can do is create a mask to ensure that we never end up with those odd situations. You'll see that it's on every odd number that it occurs, and every even number works. But again, that's not really an issue. The only other thing that I'd like to mention over here is that the centers of these two should match. If we change the center of the second ramp, so just moving this to the side, you'll see that all of those lines still stem from the center of our radial ramp. That's why we want these two to always match. To do that, it's really as simple as just copying the parameter from your concentric ramp and pasting it into your radial ramp. And now if we ever move this around, it moves as we would expect it to. Perfect. So let's give this a bit more of an interesting tile pattern to work with. We can change this to something like herringbone and then reduce the divisions, something like that. Now, to get rid of all of these lines towards the outside, we're going to make a few masks. So let's go ahead and take this and turn it into a few masks that we can use. So let's use a remap. We're going to drag our low end all the way up and then complement the ramp. So that gives us the outermost edge of the circle. So anything outside of this should be pure white. We can duplicate this. And then if we shift and click on both of these points and drag them all the way over to the start, that'll give us the center. So we now have the outside and the center. And let's also find that ring, that gradient over there. So to get the gradient, we'll once again duplicate this ramp over. And the shape that will give us that is to simply add 2 points at the start, reducing this one to a value close to 0. And that's going to give us our third mask. So we now have 3 masks to work with. So we have our tile pattern that's being sampled up here and the 3 masks down here. So let's put our 3 masks into a network box. And we can call this masks. We will add 3 outputs to this, each one of them just being mono. Dive inside, add an output node, plug each one in, then go up a level. And as we can see, output 1 is outer, output 2 is inner, and output 3 is ring. So now we have our 3 masks, all from a single subnet. And now we can take this and we can do a multiply, where we multiply it by the ring mask. So that cleans up our tiles quite nicely. The only other thing I'm going to do is on the tile pattern, just increase the inset. I think that looks a bit better. And one other thing, if your tiling isn't working correctly, you can also go down to the multiply constant that we're using for the radial ramp and just set this to an odd value, something like 3 or 5, and that tends to fix it. So now we have a perfect tile. Okay, so let's take this tile and do something interesting with it. Looking at this, I think it would be cool if we had some sort of emblem or symbol in the middle, and so we can rasterize some geometry to put in the middle of that. What we'll do is a sup import, and inside of the sup import, let's just go ahead and drop some sort of geometry. We can use a rubber toy for this, and then we can go up a level and rasterize it. So we'll use a rasterize setup. This is going to set up the required inputs for a rasterized geometry. Then we can rasterize our geometry, and we have that. By default, it gives us the alpha, but that's not what we're going to be using. But what we actually want to focus on right now is the framing of this. The reason it's framed so strangely is because it goes from the -1 to 1 space. So all we have to do is use a match size. Plug this in over here, go up a level, and it should now fit into that box. We can also use scale to fit. That will allow us to adjust the size using the target size over here. And that will fit more closely towards the center. I'm also going to rotate this rubber toy by 90 so that we're looking from the top. And now we have that. But we don't want just an alpha. It would be nice if we had depth. So let's go to our rasterized geo, quick setup, add depth from I. And then we want to equalize that just to make sure that the range is in a usable range. There we go. So we have our tiles and we have Flippy. And I think it would be cool if we added a ring around Flippy and then put him on the inside of this. So go ahead and use an SDF shape. The basic circle will be fine, and we'll be using an SDF to mono, setting the operation type to onion skin to get an outline, and then reducing the ISO offset to shrink it down. Then we can do a maximum operation between these two, between mono and Flippy, And there we have a nice little badge that we can now put in the middle of each one of these. So of course we can put them together already, but I'm going to show you a different way so that we can ensure that these two streams are separate until we actually want them merged together. The thing that we're going to be doing is another SOP import over here. In this one, all we're going to do is place a grid on the XY plane with a size of 2 by 2 and just 3 rows and 3 columns, like that. If we go up a level, we can now use a stamp point, and we're going to stamp our tiles down here. And you'll see that they end up quite small. So we can increase the size to something like 0.5. So this one is going to be our tile stamp. Now let's also do a stamp for our rubber toy. So we'll plug this in over here. And we'll obviously want this a lot smaller, and it will be difficult to compare. So let's do a maximum operation between these two so that we can more clearly see what we're doing. And then just reduce the size for our emblems, just until they fit into the middle like that. And we can rename that stamp to emblem stamp. And then the last thing that we want is just the mask for this, because it'll be extremely useful having a mask for each one of these. So we'll do one for the ring stamp. So we'll grab the ring and we'll stamp that, making sure that the size of this is the same as the size on our tile stamp. So once again, just copying the parameter for scale, pasting it down here. So now those two match perfectly. That'll be our ring mask stamp. Duplicate this down. And let's also just take the entire thing as a stamp, just like that. And we can call this islands stamp. Now, again, it would be nice to have these all into a single network. Let's just drop a null so that it automatically creates our outputs for us. So grab the stamps and just plug them in here. So just click and drag over here, create a subnet. And the first input we can rename to emblem, as that's what's coming in. The second input is our ring mask. Our third input is our tiles. And that means that the last one is our outer mask. Now, these aren't as important as our outputs, so let's sort those out. Our foreground is our emblem stamp. Second input, ring stamp. Third input, tile stamp. Fourth output, island mask. And just like that, we now have our output. So we can now delete this null. Okay, so now we have this. And because we have all of these masks, it's really easy for us to do further blends. So let's use a tile pattern right here. This one is going to be a different pattern. We can do something like windmill. And then we're going to use a blend. We're going to blend with this as our background and the second tile as our foreground. And then we can use the mask that we created. So we have the island mask to use as a mask over here. And I mixed up the inputs, so just swap those around like that. If you want, you can use a dilate or erode. That'll add a ring around each one. We can remove the soft edge and reduce that radius, right? So it's a bit more distinct. Next, let's add some patterns in between these. And a cool way to do that is by grabbing this island mask that we have right here, using a blur, pushing that blur up to something like 0.1. So it's quite a large blur. And then we can use a remap. And the nice thing about this is that we can close in on a particular range. So we can bring this all the way in over here, bring up that low end, and we can flip that if we want the inverse. And then we can do a separate patterning over there. So if we were to do another tile, let's make this one hopscotch. And once again, we'll blending these two together. And for this one, we'll use the mask again. So drag that mask in and correct our inputs. And now it would be nice to have a line around each of those as well. So we can use a dilate and erode, removing the soft edge, dilating it in, and then using a difference. So we find the difference between the two of these, and that'll give us that outline. And if we want, we can subtract it from what we have. So subtract over there, and that gives us those outlines, which we can, of course, adjust. Now it's all about getting creative when it comes to actually adjusting all of this. And so what I've shown you is most of this tutorial. From here, it's just going to be, once again, adding variation. But the main thing that I wanted to show you is how we can start to implement a bunch of different systems together and do things like UV warping, and stamping of particular inputs to get really interesting results. So already, if you just put this into a preview material and use this as the height, increasing divisions, reducing the height, you can see that we already have some very interesting patterning going on. One thing is that you'll see that your depth over there is inverted on all of your emblems, and that's simply because depth is lower when something is closer to the camera. And all we have to do to correct that is use a remap, flip the ramp around, and add something on the 0 end, just to make sure that the background remains black. You'll see that if we don't have it, it's white. We want the background to be black. And now the part closest to camera stands out the most. You can also increase your input ranges. So if you want that emblem to stand out the most, you can increase the output max to something like 3 or 4, and you'll see that it stands out more than everything else. So like I said, that's most of it, but let's go ahead and add some variation. One nice thing to do is to use a connectivity, segment by connectivity. We'll go down here to make our adjustments. This will give us unique IDs per tile, and we can even use this to generate UVs. So we can do UV map by ID, and if we plug an ID in, you'll see that it gives us what we've had before, where each one of these has a 0 to 1 space UV coordinate. We can then use transform UV, so a UV transform right here, plugging this into first input and our IDs into the seed, going down to the rotation, giving them random rotations, taking that, using a ramp mono, as well as a UV sample to take our samples and sample our ramp. This is going to give us those unique gradients per tile, and you will see that it's being cut off and repeated. That's simply because some of these are ending up too small. So you can go and reduce the uniform scale so that we end up with that. And that's going to be a great thing to multiply with our subtract over here. So we can multiply our height by this unique tiling that we've done at the bottom. And if we take a look at our height now, you'll see that each one has a slight variation, right? So none of these bricks are placed perfectly straight. And that is going to look really good when you go to rendering, because the light is going to catch the different edges and it's going to add a really good look. You can do the same thing when it comes to roughness. So if we were to take this, we could once again put this into a network. And the reason I'm doing this network is because sometimes the only thing that we want to change about what we've done in there is the ID. So we can just call this ID to gradient. And if we duplicate it, we can just dive inside. Then on our UV transform, we can just adjust the seed, right? So if we go up a level, these two are going to give us different outputs. That's quite nice because we can use the one for our height and the other one for something like our roughness. So let's put that into roughness. Perhaps also blur our height slightly, just to smooth out those edges. Now let's go in and hit this with some color. So we'll use our height to ambient occlusion, taking our height map, pushing up the height scale slightly, taking that, using a multiply, taking our original height, so this is just the one that's a black and white mask, taking our height to ambient occlusion, and then we can adjust the influence that the ambient occlusion has on this. And now we can use a ramp RGB, taking this into position, bringing up the low end, bringing down the high end, giving it some colors, maybe green on the low end to give it a patinaed look, plug that into base color, and then let's set this to metallic. So metalness up to 1. And let's see how that looks as a render. So just as a refresher, we can just do whatever geometry we want over here. Maybe I'll do a sphere. Go to the stage level, use a scene import. So scene import all, drop a camera, a calmer physical sky, a render geometry settings, and then choosing our primitive, scrolling down, enabling dicing, setting our dicing, and doing a render. So if you want the file that was used for the intro image, I will be including it for download, and you can take a look at what I did there. Most of it is just layering of various color variation and texture variation, and even adjusting height, because there are some really easy changes that you can make that really add to this. For example, where we have our height going in here, we can multiply it by any one of the masks that we've had before. So if you use something like a multiply, grabbing any one of your masks, plugging it in over here, adjusting the influence, you can see that that's an easy way to reduce certain areas' heights. And we can even use this down here as a mask for that, so that it only applies to certain areas, or even invert this mask. So invert, so that those are still raised. We can also use that for an HSV adjust. So let's just make an adjustment here, say reducing the saturation, decreasing the value so it's darker, and then using any one of our masks for that. Perhaps inverting that as well, getting a minimum with this one. And then we can see how that looks. And now we've got a really complex pattern that we created with various tiling types, as well as with custom UVs that we created ourselves, and it looks pretty good. So I do hope that you enjoyed this video. I do hope that it helped you. If you have any questions or comments, please feel free to leave them down below. I'm most likely to reply to them over on the Side Effects website, or if you're on the Houdini Academy Discord, but I'll try my best to get to every one of them. So thank you for watching. I'll be seeing you in the next series coming soon. So until then, bye.